how a pump in general is classified to understand the whole concept of the type of pumps easily. Refer to the chart shown here. This chart broadly classified pumps into two categories, rotary and positive displacement. Under positive displacement, piston type, diaphragm type are the pumps that are widely used. Under the rotary type, you can further classify pumps into fixed volume pump such as gear and lobe. And the biggest category under the rotary type is centrifugal pump. There are multiple ways to classify the centrifugal pump. Refer to the chart shown here. Different types of centrifugal pumps are used in the industry based on the requirement. They are classified based on the design code, impeller type and numbers of the impeller, applications and so on. This chart covers the most common way to organize these pumps. Now, one thing that you have to keep in your mind is that the same pump can be a part of two or more groups. For example, pump shown here is a single stage, radial flow, single volute, single suction type. You can see that it comes under lots of categories. So let's start with flow type. Depending on the flow type, pump can be radial, axial or mixed flow type. In the image here, you can see the radial, axial and mixed flow type design. In radial flow, fluid take a 90-degree turn from the suction. You can see that fluid enters at the impeller eye and get exited radially from the impeller. The most centrifugal pumps come under this category. Fluid enters through the horizontal suction flange and leaves through the vertical discharge flange. That means a discharge is perpendicular to the pump shaft. This design is used when you want to increase the discharge pressure with a limited flow of the fluid. You can simply say that it is a high pressure, low flow rate pump. Most pumps used in oil and gas will fall into this category. When the fluid flows parallel to the pump shaft, it is called an axial flow pump. In this type of pumping, liquid moves parallel to the pump shaft. Here you can see that the liquid passes through impeller. This action resembles working of propellant. This pump is useful when handling a large amount of fluid with very little pressure head. Dewatering pumps, water circulation pumps are everyday use case of the axial flow pump. As the name suggests, when the fluid flow is mix of both radial and axial, it is called mixed flow pump. It is a trade-off between radial and axial type pumps. It can handle a high flow rate with a decent increase in the pressure head. If you want to learn more about centrifugal pump principle, operation and design, you can check the full course available on my website. It is 7-hour long course covering every aspect of the pump that will make you super confident about a centrifugal pump. The second method to categorize pump is number of stages. Depending on the requirement, 2 or more impeller can be used in the pump. The image shows the single stage pump with a single impeller on the shaft and multiple stage pump with many impeller on the same shaft. Each impeller is one stage. Single impeller design is useful for a large flow rate with relatively less increase in the pressure head. When you need very high head at discharge, the multi-stage design is used. In this case, impellers are connected in the series so that each stage will boost the fluid pressure. Next is use of the design code. When it comes to using code for the pump design, these two are used in the most cases. API 610. This is the most widely used in oil and gas, petrochemical and similar process industries. It has its own pump classification such as Orang or OH type, vertical suspended or VS, and BB type, which is between bearing. Second code is ISO 5199 or ISO 2858 or DEN 24256. Now this DN 24256 is merged with ISO 2858. These standards are used for all type of pump design. I haven't worked with this ISO standard, so I don't know much about this. The fourth method to classify the pump is based on the volute casing type. Pump casing can be of a single volute type or double volute type, as shown in the image. The most pump you will see inside the refinery will be of a single volute type. Double volute has an advantage over the single. It will minimize the shaft deflection when the pump is operating outside the best efficiency point, which is also known as BEP. If your use case is not fixed and there is a frequent chance to run the pump outside BEP, double volute is preferred. In double volute, exit of the liquid from the impeller is distributed in 180 degrees. So half of the liquid pass to this portion and the remaining half handle the other liquids. This will distribute the load and reduce the stress on the pump body and shaft. On this chart, you can see that the radial force distribution of a double volute casing is much flatter than the single volute casing. The fifth method to classify pump is based on case design. There are two types of case. The first is the radial split case. The radially split pumping casing opens perpendicular to the shaft axis and parallel to the impeller. The second case design is axial split. In this design, the pump casing is spliced into two halves that get separated horizontally, or you can say that parallel to the shaft axis. It sounds difficult to understand, but just look at the image. You will immediately know what I am trying to explain to you. It is the way you open a pump for any maintenance. Next type of centrifugal pump based on the vertical or horizontal shaft position. In the case of vertical pump, the pump shaft is in a vertical direction and the pump is usually installed in the sump. This type of pumps are used in a limited space. Pump in borewell and sump collection are some of the examples of this pump. Horizontal pumps are more widely used as it is easy to maintain. In this type, a shaft is horizontal plane. The impeller can be overhang or between bearing type. The image shows both types. Based on the number of suction, centrifugal pump can be single or double suction type. The most centrifugal pump has a single suction design. However, when the flow rate is very high, single suction will not be enough. In this case, double suction pumps are used. The impeller of this type of pump is designed in such a way that liquid enters from the both sides of the impeller as compared to single side in normal case. Now don't get confused with the name. Even in the double suction pump, you have a single suction and discharge flange. It is the design of impeller and casing that are different. The image shown here is single and double suction centrifugal pump and impeller. The last way to classify the type of centrifugal pump is depending on impeller position. The first is overhang. In this type, the impeller is supported through a single bearing. The impeller is attached at the end of the shaft. This design facilitates both horizontal and vertical installation of the pump. The second is between bearing. In this type, the impeller is installed on the shaft and the shaft is supported by bearing at both ends. Horizontally installed multi-stage pumps come